Slope is a fraction. And before we get on to talking about how you get that fraction, I first want to look at how do you solve these fractions, or how do you simplify these fractions. When you have math going on the top and math going on the bottom of a fraction, you need to first do the math on each top and bottom separately before you do anything together. So on the top here I have -1 minus 4, that gives me -5. And on bottom I have two negatives, so I'm going to make a plus, and we have 4 plus 3 is 7. So the fraction here is -5/7, and that's how we're going to leave it. We don't do decimals with slopes and things like that. Okay, as you guys know, you've heard about slope many, many, many times. Slope is rise over run, which means if you're looking at the graph, it's from point to point. You go up and then over. The variable we use, or the letter we use to stand for slope, is m. M, if you ever see an M, they're talking about slope. And then the subtraction fraction, I really like that word, subtraction fraction. But the subtraction fraction that you use is you have to take the second y value minus the first y value over the second x value minus the first x value. Now you guys might see that sometimes. I personally don't like to use that just because I found that people get confused by it. So instead I like to do the table and loop-d's. And you guys probably remember that from Algebra 1, but we're going to practice that here. So here's the idea of this problem. It says a line goes through the point -3, 5, and 2, 1, and you're supposed to find the slope. So the idea is you have a point, and you have another point, and we're supposed to find the slope. Now, you could do the subtraction fraction, which would be, let's see, the y value. This would be the second y value minus the first y value. So we have 1 minus 5 over the second x value minus the first x value. So that would be 2 minus -3. And so we have 1 minus 5 is -4. And then this would be 2 plus 3, which would be 5. So the slope is -4/5. However, I would much prefer, and it tends to be simpler and less possibility of mistakes, is to make a table and put your points in the table. This -3, 5, we're just going to go ahead and put it in there. -3 and 5 across from it. And then we have 2 and 1. If you remember back to Algebra 1, I talked about doing loop-d's. So I say, how do I get from 5 to 1? What math do you have to do to get from 5 to 1? And you would subtract 4. And then on the other side, what math do you have to do to get from -3 to 2? Well, you'd have to go up 5, so you add 5. And now for the slope, remember the y value is on top, so our y loop-d goes on top, and our x loop-d goes on bottom. And there would be the same exact slope we found before, only this way you have a tendency to do a better job and not make mistakes. So it would be a good idea for you to try and do this one by yourself, so you can pause me now if you want. But what we do again is we're going to put the x and y values in there, -2, -4. Make sure that they look just like they do in the bubble. They go straight across from each other. And then 3, 1. We'll do our loop-d's. To get from -4 to 1, we add 5. To get from -2 to 3, we add 5 also. And so my slope is 5 over 5, which reduces to 1. So my slope on that one is 1. Now the types of slopes. These are the 4 different kinds of lines you're going to see. Now if you remember back in Algebra 1, I talked about the little dude who walks on the line from left to right always. Now this little dude would be going up the line. This would be a positive slope. When the line is going up, it's a positive slope. Okay, over here on this one, the little dude would be going down, so this would be a negative slope. Now if you think about it, on this one going straight across, if you think about the floor, what would you say? What kind of slope does the floor have? You would say that it has no slope, right? It's not going up, it's not going down, it has no slope, or we would call this 0. And then over here on this one, it's going straight up and down. This doesn't even pass a vertical line test because it is a vertical line, and so this one would be considered undefined when you have a vertical line. So here we have this question, what type of slope does the line that goes through the points have? And so what we're going to do is we'll still set up a table. We're actually going to find the slope. We could also graph it to see what it has. but we might as well, since I don't have graph paper, I'm just going to go ahead and put my points in there, do my loop-de's, add 6. Over here I add 0. And so the fraction I get is 6 over 0. Remember, you cannot divide by 0. That's an illegal option. So when we have that, we consider this to be undefined. Now if we actually graphed the points, we would find that we had a vertical line. And then we have the question, which line is steeper? Now this is an interesting question, because think about how things are steeper. Steeper would mean you would rise more than you would run, right? Because if I look at a picture, this is steeper than this. It's like saying stairs going upstairs is steeper than bleacher stairs, right? So if you look at it, your rise would be bigger than your run. That makes it steeper. So the top number being big and the bottom number being small makes it steeper. Okay, the more shallow the line, the rise is smaller and the run is bigger. So when it's small on top and big on bottom, then you're looking at a shallow rise. So our question is, which one's steeper? So if we look at line 1 and put those in a table, we've got 2, 3, 4, 7. 3, we add 4 to get to 7. For 2, we add 2 to get to 7. So this one gives us 4 over 2, or 2. That's a pretty steep slope. If we go to the line 2, we've got negative 1, 2, and 4, 5. From 2 to 5, we go up 3. From negative 1 to 4, we go up 5. So we've got 3/5. Now if we look at which one's bigger, you should pretty easily recognize that 2 is bigger than the fraction 3/5. So which line is steeper? Line number 1 is steeper, because the slope is... Okay, so then we go down to our next concept of parallel lines. So think about parallel lines. Parallel lines are lines that have the exact same slope. Their slopes have to be equal. If they weren't equal, then the other one would be going at a steeper or more shallow rate, and at one point then it would cross. So for lines to be parallel, they need to be going at the exact same slope. They never intersect. And so we can find out for sure if we have parallel lines by finding their slopes. If their slopes are the same, we've got parallel lines. So we have negative 3, 1 and 3, 4. I add 3. I add 6. So for this one, it's 3 over 6, or 1/2. This is for line 1. For line 2, I put my points in there. From negative 3 to 1, I add 4. From negative 4 to 4, I add 8. So I get 4/8, which reduces to 1/2. So then we know that these two lines are parallel because their slopes are exactly the same. They both reduce to 1/2. All right. Perpendicular lines. The definition of perpendicular lines is that they form a right angle. Now, that also means that if m is your first slope, then the perpendicular slope is going to be the flipped over, the reciprocal, with a negative out in front. So let's just say m is 1/2, then m2 is going to be 2 over 1, it'll be flipped over, and then we'll put a negative out in front. If m was negative 5, then the reciprocal, or the slope of the perpendicular line, would be 1/5 positive, because negative 5 was negative, and then 5 over 1 would be the fraction that we would flip over. Now if you look at both of these, if I were to multiply both of these together, so 1/2 times negative 2 over 1, I get negative 2 over 2, which is negative 1. If I take negative 5 over 1 times 1 over 5, I would get negative 5 over 5, which is negative 1. So the idea is, if you were to multiply the two slopes, you should get negative 1 every single time, because the reciprocals are going to cancel out. One's positive, one's negative, so you get negative. So let's check here. I'm guessing, if I'm right, these two lines, 1 and 2, are going to have perpendicular slopes. So let's check it out. We've got negative 3, 3, and we've got 2, 3. So 3 plus 3 is 0, or 3 to get to 3 is 0. Negative 3 to 2 is 5. So we've got 0 over 5, which reduces to just 0. If you think about that, that's a line going straight across. So I'm thinking this next one should be straight up and down if it's perpendicular, which means we should get undefined. Interesting. So we put in negative 2, negative 3, and then 3, negative 1. To get from negative 3 to negative 1, we would add 2. And to get from negative 2 to 3, we would add 5. So we get 2/5. Interesting. They're not perpendicular at all because they're not negative reciprocal. So I guess these are not perpendicular lines. So here we have an interesting question. Which line is perpendicular to the line that goes through these 2 points? So we'll first have to start by finding this slope. And then we're going to look at this slope and see which one is perpendicular. So let's start with the original line. We've got negative 3, 1 and 4, negative 2. So here we subtract 3. Over here we're going to add 7. So the slope for this one is negative 3 over 7. So I'm looking for either line 1 or line 2 to have the slope positive 7 over 3. So let's check out line 1. For line 1, I've got 4, negative 3 and 1, 4. I add 7 on the right, and on the left I subtract 3. So I'm going to get a negative 7/3. Now it's flipped over like I want, but it's negative still, and we don't want to have negative. So let's check out line 2. We've got negative 3, and 0, 4. So from negative 3 to 4, I add 7. From negative 3 to 0, I add 3. And so my slope is 7 over 3, which is what I want. I wanted a positive version of that. So line 2 is perpendicular to the above points. And then last here, we're supposed to tell whether the lines are parallel, perpendicular, or neither. You know, we get stuck in this idea of they have to be either parallel or perpendicular, but it is possible that they're neither, and they're just two lines that cross at some point. So let's check it out. Line 1, I've got point 1, negative 2, 3, negative 2. So let's see here, I add 0. Over here, I add 2. So for line 1, I get 0 over 2. For line 2, let's see, I've got negative 5, 4, and 0, 4. I add 0, and let's see, I add 5, so I get 0 over 5. Now either way, both of these reduce to 0. So we're going to say that for line 1 and 2 in part A, that they are parallel because they have the exact same slope. For line B, or sorry, for problem B, we've got line 1. That would be negative 2, and 4, 1. So I go from negative 2 to 1 is add 3. From negative 2 to 4 I add 6. So I've got 3 over 6, which reduces to 1/2. For line 2, put my points in there. From negative 3 to 5 I add 8. From negative 3 to 1 I add 4. So I get 8 over 4, which reduces to 2. So here I've got reciprocals, but I don't have a negative one. They're both positive. So these are going to be neither. Now if you go to page 78, example 5, it talks about ladders, and that the most steep you should ever have a ladder is saying that it can be at a height, it can be at a height, so if this is a ladder going up here, it can go up 12 feet and 3 feet on the bottom. And so it asks, what's a recommended slope for a ladder? Well, we're going to take rise, 12, over run, 3. And so the recommended slope would be a slope of 4. And then it says, find the minimum distance a ladder's base should be from a wall if you need the ladder to reach a height of 20 feet. So now they're saying, I want this to be a 20, so what should this be? Now, this to me, I'm sorry, is screaming proportion. I've got one situation here and I've got another situation here, and they're supposed to be at the same slope. And so you can set up a proportion. We already know from up here that 4 over 1 is appropriate for the slope. So then on the bottom we're going to have 20 over x. And then it's just a matter of solving for x. Hopefully you can see that 4 times 5 gives me 20, so 1 times 5 means that x should be 5, or 5 feet from the wall.